Here we are in the last lecture for Module 4 about classes and objects. And as a reminder, here are the module learning objectives. And we've finally gotten to the one where we're going to design a new class together. So at this point in the module, we've discussed the foundational ideas behind the object-oriented paradigm, and we've discussed how to use those ideas in a C# program. Now we're going to step back from the programming and do a higher level design activity to design a class. Before we actually do that, you should take this in-lecture quiz. So before we can design our rubber chicken class, we have to think deeply about our game design and really decide what role does the rubber chicken play in our game. Now you might think that the player avatar would be an awesome thing to use the rubber chicken for. Sadly, not this time. This time, we're going to design the rubber chicken as a weapon. So it won't be a very limited weapon, of course, because rubber chickens are pretty flexible. I hope you got that. Rubber chickens can be either melee weapons, as you might be able to imagine, and they can be ranged weapons as well. So the way we're going to approach this is first, we're going to think about the state. What kind of information do we need to store to capture the characteristics of the rubber chicken? And then we'll move on to behavior. Now it's important for you to realize that as we design real classes for real games, we end up iterating between state and behavior as we go along. We might discover we need some new behavior as we're developing our game, at which point we probably need to go back and add some more state as well. So this is sort of an atypical small example. We'll cover state and then we'll cover behavior. So you should now go to the in-lecture quiz, which really has you pause and think about the state of the rubber chicken for a while, and then come back and we'll talk about it. Okay, so there is some reasonable state information that we might store for a rubber chicken that we're going to use as a weapon in our game. First of all, we're going to need location. We need to know where the rubber chicken is so that we can do collision detection. Especially if you're good at using your rubber chicken weapon, you're going to actually collide that rubber chicken with other stuff. And the way we actually figure out that that's happened is by using the location of the rubber chicken. Rubber chickens also have velocity, especially when they're used as a ranged weapon. So if we were to throw the rubber chicken, it has a particular velocity. And so we're going to need that velocity so that we can change the rubber chicken's location over time. We also have a range for the rubber chicken. How far can you throw it, for example? And so, you get upgrades, you get rubber chicken upgrades as you work your way through this fictional game that hopefully no one will ever build. So you get these upgrades to your rubber chicken, and so you can fling your rubber chicken further if you increase the range through those upgrades. Accuracy, you also have accuracy with your rubber chicken. You can't just fling it in any direction and expect to hit stuff. You need to actually be good at aiming your rubber chicken. Wow, there are some weird things I'm saying today, but that's okay. You have to be able to aim your rubber chicken with some level of accuracy, and again, you might be able to upgrade that stuff. Rubber chickens, when we do get that collision with something, rubber chickens inflict damage. Now that damage could be variable, right? It could be based on how far away the rubber chicken was, its velocity when it strikes whatever it hits, because if you use it as a ranged weapon towards something close, it will probably do more damage than if you use it as a ranged weapon and you throw it far away. So there's some damage that's probably variable, unless we stuff our rubber chicken with a C4, in which case it probably always inflicts about the same amount of damage when it hits something and explodes. The last thing we probably want to store, which you may not have thought of, is who is the owner of this rubber chicken. And it's not because we need, somebody to feed and care for this rubber chicken. It's because usually what happens, especially in games with weapons, especially in games with ranged weapons, is if you inflict damage by throwing your rubber chicken towards something, and the rubber chicken hits and destroys, oh, I don't know, something, imagine something, hits and destroys something, usually the owner of that particular projectile, in this case, will end up getting points or upgrades or something, right? So you actually need to keep track of who is the owner of the rubber chicken so that we could allocate those benefits to whoever damaged something with the rubber chicken. Okay, so if that hasn't been disturbing enough to you, that's great. Hang with me. We'll see how much more damage we can do. So you should now go do another in-lecture quiz where you really think about what kind of behaviors should this rubber chicken have, and then click continue and we'll move on together. Okay, so there are a number of reasonable behaviors that this rubber chicken could have. For example, we're going to want to update this rubber chicken. Remember we haven't talked yet, but we will talk soon about a game loop where we update the game world so that we sort of update the status of everything in our game world and then we draw it. So we will want to update the rubber chicken periodically, every frame in our game in general, so that the location changes based on the velocity. So we definitely want the rubber chicken to expose an update behavior so that we can change its location as we go along. We might also want our rubber chicken to exhibit an explode behavior, so we could call a method telling the rubber chicken to explode. That really only applies if we're using the whole C4 rubber chicken approach, but it's worth thinking about. We also may, if we have a more interesting game, we may have the rubber chicken play an animation. It could play one animation as it flies through the air, another animation right before it realizes it's going to explode, because rubber chickens are pretty self-aware and they know that's going to happen. And a variety of other animations just for humor. If you're building a game with rubber chicken weapons, you probably are keying into the humor idea, so playing some animations might be interesting. I have in fact done this class design exercise in a sort of normal, well, not a normal classroom, a classroom of my game development students, let's put it that way. And so I felt compelled to tell you that there is one unreasonable behavior, at least for the rubber chicken, and most rubber chickens are not going to in fact turn into a live chicken sometime in the game. That would just be wrong. This is not Pinocchio with rubber chickens. So we probably are not going to convert our rubber chicken into a live chicken. Okay, so that was sort of a short and sweet, what thought process do we go through to actually design the classes in our game? And that's probably enough for sort of the informal figuring out what you need as you build classes in your games. More advanced object-oriented analysis and design uses much more formal tools to actually figure out state and behavior and so on. And so in later classes that I teach at UCCS, we actually cover those kinds of things. But this sort of informal thinking about it kind of process, including understanding that you're probably going to iterate and practice, is a reasonable first taste towards how we actually design stuff. So that's the end of Module 4. Next time, we'll actually move on to talking about the XNA framework.